other people. Everyone is interested in other people. Everyone has relationships with other people. And they're interested in these relationships for a variety of reasons. Good relationships, bad relationships, annoying relationships, agnostic relationships. And what I'm going to do is focus on the central piece of an interaction that goes on in a relationship. So I'm going to take as inspiration the fact that we're all interested in interacting with other people. I'm going to completely strip it of all its complicating features, and I'm going to turn that object, that simplified object, into a scientific probe and provide the early stages, embryonic stages of new insights into what happens in two brains while they simultaneously interact. But before I do that, let me tell you a couple of things that made this possible. The first is we can now eavesdrop safely on healthy brain activity without needles and radioactivity, without any kind of clinical reason. We can go down the street and record from your friends' and neighbors' brains while they do a variety of cognitive tasks. And we use a method called functional magnetic resonance imaging. You probably all read about it or heard about it in some incarnation. Let me give you a two-sentence version of it. So we've all heard of MRIs. MRIs use magnetic fields and radio waves, and they take snapshots of your brain or your knee or your stomach. Grayscale images that are frozen in time. In the 1990s, it was discovered you could use the same machines in a different mode. And in that mode, you could make microscopic blood flow movies from hundreds of thousands of sites independently in the brain. Okay, so what? In fact, the so what is, in the brain, changes in neural activity, the things that make your brain work, the things that make your software work in your brain, are tightly correlated with changes in blood flow. You make a blood flow movie, you have an independent proxy of brain activity. This has literally revolutionized cognitive science. Take any cognitive domain you want: memory, motor planning, thinking about your mother-in-law, getting angry at people, emotional response, it goes on and on. Put people into functional MRI devices and image how these kinds of variables map onto brain activity. It's in its early stages and it's crude by some measures, but in fact, 20 years ago, we were at nothing. You couldn't do people like this. You couldn't do healthy people. That's caused a literal revolution. And it's opened us up to a new experimental preparation. Neurobiologists, as you well know, have lots of experimental preps. Worms and rodents and fruit flies and things like this. And now we have a new experimental prep: human beings. We can now use human beings to study and model the software in human beings. And we have a few burgeoning biological measures. Okay, let me give you one example of the kinds of experiments that people do. And it's in the area of what you'd call valuation. Valuation is just what you think it is. You know, if you went to and you were valuing two companies against one another, you'd want to know which was more valuable. Cultures discovered the key feature of valuation thousands of years ago. If you want to compare oranges to windshields, what do? Well, you can't compare oranges to windshields. They're immiscible. They don't mix with one another. So instead, you convert them to a common currency scale, put them on that scale, and value them accordingly. Well, your brain has to do something just like that as well. And we're now beginning to understand and identify brain systems involved in valuation. And one of them includes a neurotransmitter system whose cells are located in your brainstem and deliver the chemical dopamine to the rest of your brain. I won't go through the details of it, but that's an important discovery, and we know a good bit about that now. And it's just a small piece of it, but it's important because those are the neurons that you would lose if you had Parkinson's disease, and they're also the neurons that are hijacked by literally every drug of abuse. And that makes sense. Drugs of abuse would come in, and they would change the way you value the world. They change the way you value the symbols associated with your drug of choice, and they make you value that over everything else. Here's the key feature, though. These neurons are also involved in the way you can assign value to literally abstract ideas. And I put some symbols up here that we assign value to for various reasons. We have a behavioral superpower in our brain, and it at least in part involves dopamine. We can deny every instinct we have for survival for an idea, for a mere idea. No other species can do that. In 1997, the cult Heaven's Gate committed mass suicide predicated on the idea that there was a spaceship hiding in the tail of the then visible comet Hale-Bopp, waiting to take them to the next level. It was an incredibly tragic event. More than 2/3 of them had college degrees. But the point here is they were able to deny their instincts for survival using exactly the same systems that were put there to make them survive. That's a lot of control, okay? One thing that I've left out of this narrative is the obvious thing, which is the focus of the rest of my little talk, and that is other people. These same valuation systems are redeployed when we're valuing interactions with other people. So this same dopamine system that gets addicted to drugs, that makes you freeze when you get Parkinson's disease, that contributes to various forms of psychosis, is also redeployed to value interactions with other people and to assign value to gestures that you do when you're interacting with somebody else.